that's just, if I'm taking the integral, it's like the integral of x cubed plus x squared du, but they're in parentheses, can I still split that apart into the two?
For sure. So x squared plus x cubed. Is that what you said?
Yeah, and they're, yeah, okay. Awesome. I know how to solve this if it's not combined. So I wanted to make sure we still split it apart.
Yes.
Okay, cool. And then
You can always split apart at addition or subtraction. So if this had looked like x squared times 5 plus x cubed, I cannot split that apart as the integral of x squared times the integral of garbage. But I could distribute that out and make that, yeah, plus x to the 5th, and then break those up. That I can do. Yeah. That is, in fact, how I would do that.
Make sure the parentheses didn't negate that rule.
Correct.
And then the other one is, so it's on the integral of 2 to -1.
The 2 is raised to the -1?
No, it's between 2 and -1.
Oh, got it. Okay. Yep.
2x divided by radical x squared plus 1. And I went for like u substitution.
I would go for u substitution on that as well. Now, I am not about to try to confuse anyone a couple hours before you have an exam. So I'm going to do something with that u substitution. And if you don't like it, you're going to go, right, and ignore me because we're not going to learn new things right now. We're practicing things. We're not learning new things. If I make this u substitution to let x squared plus 1 be equal to u, so that my du is 2x dx, I've got that 2x dx. There's technically a thing that our textbook shows us where we then come off to the side and I say, when x is equal to -1, u is equal to -1 squared plus 1, and I get a 2. And when x is equal to 2, u is equal to 2 squared plus 1, and I get a 5. So that when I write that u substitution, it could technically become the integral from 2 to 5 of u to the -1/2 du. And then we wouldn't plug x's back in at the end. You don't have to do that. But if you don't do that, you do have to plug the x's back in at the end. So that was just my, like, the solutions in the back of the book usually do it this way. So if you're trying to follow what's happening in the book, that's usually what the book does.
I was like, where did they find a 5?
Yeah, that's where they found a 5.
2 radical 2 minus 2i. And they were like, it's 5. And I'm like,
Yeah, so that is where they found a 5. Now, if I did it the other way, right, I like to just remind myself that this is the x value and not the u value, so that I'm like reminding myself, hey, plug that back in later. I've got that du, and because it's like a 1 over square root of u, I'm going to write that as u to the -1/2 du. So when I integrate this, I'd end up with u to the +1/2, but then we're dividing by a 1/2. So it's the same as multiplying by 2. And we're going from x equals -1 to x equals 2. So I definitely need to go back to like square root of x squared plus 1 and then go -1 to 2. So you probably did it right. It just didn't look like the back of the book because the book does this other thing. Again, don't learn new things 4 hours before a test. Yeah. Yeah. Oh, if we did the second one or the first one as it is written. So the first one as it is written, we're gonna want to break that apart to be the integral of x squared dx plus the integral of x cubed dx. So I would do each of those as a power rule, and it sounds like you try to combine those into one fraction. I wouldn't, I honestly would just quit here. I would not try to make those into a common denominator thing. Just leave it. Yeah.
One more question. So he said 4 ones where it's like if f of x is equal to cube root of x.
Okay. Cube root of x, sure. Got it.
And g of x is equal to x squared.
Yep.
And we're finding the area between the graphs.
Yep.
He gave us something to like. What I usually do is I think about the shape that each graph would make, and I can just like sort of picture which one would be on top. But he said we're not allowed to do that. We have to prove which graph is on top.
Sure. So great. Well, if I have to find the area between, how about these? How about I make that a better sentence? If I'm trying to find the area between these, I know for sure I need those intersection points. So it's going to be a little gross, but that's okay. We can handle a little gross. So I'm going to set x to the 1/3 equal to x squared. And then I'm going to cube both sides so that this says x equals x to the 6th. And then I'm going to subtract everything over. That's a 6, I swear. Factor that x out. And go, great. I got 2 things here. X could be 0 or 1. So in terms of the like prove, what he's saying is now if I think about a number between 0 and 1, I just need to know which of those things is bigger. I'm totally with you. I would rather graph this. I know that a graph of x squared looks like this, and I know that that cube root is going to do something like that. And I know that that cube root has to be bigger. So make sure that happens when you choose a number, right? Like from a very practical perspective, if you already know who's on top, I mean, fractions or decimals, either way, this is going to be a little bit gross. But what would you rather have, fractions or decimals? Great, I pick fractions. And I'm going to pick 1/8 because that's the only thing I can think of that I can take the cube root of. And 1/8, if I square it, I get 1/64. So guess what? We were right. This one's on top. From a super practical perspective, if you know what that graph looks like, strategically engineer this to work. Right? Like again, we're
he was doing with like less, this is less than x is less than something, but
I am 100% sure that if you wrote this, you would get all your points for the problem, right? He's not being crazy picky about notation, although he is using slightly more mathematically rigorous notation. The expectation isn't that you are. Yeah. I mean, you still have to integrate it now from 0 to 1, but Other questions people want answered or types of questions you want me to make up?
Can we go number 3? I know that we started this last.
Yeah, for sure. Let me pull it up.
Also, do you write on a rocket notebook?
Oh, yeah, I love my rocket books. So this one is kind of reaching the end of its life. I will say that probably they last me about a year. And then they just don't always write as well as consistently, but I do love my rocket books. So from our practice problems here, I don't remember. I feel like we did the first one, but not the second one. Does that sound right?
Yeah.
Okay. So that second one, 2x over the square root of 3x plus 4. I actually wouldn't do this with integration by parts. Unfortunately, I don't think we were given a choice.
Yeah.
Because the test said we need to do this with integration by parts. That is not how I would do this problem. So I just wanted to like put that out there. If anyone would like to see how I would do this problem, we can definitely do it a different way. But if I had to do this as integration by parts, I'm probably gonna at least want to rethink this as like 2x times 3x plus 4 to the negative 1/2. As a general rule with integration by parts, I'm kind of stuck because these are both algebra, which is why I personally would not do integration by parts. If I have to, the thing that I'm going to choose for you is whatever part I'm going to have a derivative headed towards 0, right? Like if I took enough derivatives, would I get to a number or 0? And if I take a derivative of 2x, I'm going to get to a number. So that's what I would choose if I had to do this as integration by parts. I haven't even looked at the solutions and I don't know if that's what he chose, but that's why I would make that choice. So if I come off to the side and u is 2x, then that means everything else is dv. That 3x plus 4 to the negative 1/2 dx. Well, the derivative of u is straightforward. Du is 2 dx. But over here, we still have a gross integral to do. It's not horrific. I can probably get there in my head, but let's assume that at least one person doing this integral would prefer to actually write it out. So here, I'm going to let u be equal to 3x plus 4 so that du is 3 dx. And I can rewrite that as u to the negative 1/2 times 1/3 du. To integrate that, not ignoring the question in the chat, I actually don't know if the solutions are incorrect. I'm going to get an answer first and then we'll check. If I add 1, that's going to be u to the 1/2, but dividing by 1/2 is the same as multiplying by 2. So my v is 2/3 of 3x plus 4 to the positive 1/2. All of that just so that I can rewrite this with some ultraviolet voodoo. I don't know how much space I need, so I'm coming all the way down here. So u, which is 2x, times my v, 2/3 of 3x plus 4 to the 1/2 minus the integral of v du, so 2/3 of 3x plus 4 to the 1/2 power times 2 dx. And I would take a minute to get those numbers out in front first. So I'll clean this up a little bit. That's 4/3 of x times 3x plus 4 to the 1/2. A 2 and a 2/3, I'm looking at minus 4/3. And the integral of 3x plus 4 to the 1/2. And we're going to make exactly the same u substitution we made moments ago. I'm going to let u be equal to 3x plus 4. So my du is 3 dx and 1/3 du is dx. I wrote a 4/4 when I actually meant to write a 4/3. So I've got 4/3 of x times 3x plus 4 to the 1/2 power minus 4/3. And now I'm doing my u sub. So I'm going to have 1/3 the integral of u to the 1/2 du. Yeah.
How did you get the 1/4?
3, how about 4/3? I don't know. I'm just having some trouble with that 4/3 today. It does not want to write itself correctly.
Where'd you get the 4/3? Oh, is it from this?
I got the 4/3 here because I had 2/3 and I multiplied by 2.
Yeah.
So I combined those numbers together and pulled them out front. Yes. If I were squaring it, it would be 4/9, but I'm just multiplying it by 2. Yeah. But I want to make sure I haven't made more mistakes. So like, absolutely, let's make sure we're doing okay. Yeah. This 1/3 from my u substitution. It's okay to put it in here as du divided by 3. I just put the over 3 out front. Yeah. Okay. I'm looking at 4/3 x times 3x plus 4 to the 1/2 minus 4/9. There's your 4/9. When I integrate u to the 1/2, I'll have u to the 3/2. But dividing by 3/2 is the same as multiplying by 2/3. I'll go ahead and give myself a plus c before I forget. And that's going to mean I'm looking at 4/3 x times 3x plus 4 to the 1/2 power minus 8/27 of 3x plus 4 to the 3/2 power plus a constant. Now, let's go see what he got. Dun, dun, dun. Oh, that's the template. Never mind, that's not helpful. Hold on. Scrolled the wrong way. Now, there are lots of different ways that we can read this. But that already looks the same as what he got, so I'm not going to bother rewriting it in any other way. So I don't think there is a mistake on the solutions to this problem anyway. Oh, for problem 1, let's take a look. Problem 1, part 2. Did we already find a mistake on those? I can't remember. We were looking at these the other day, but I'm happy to go back and do problem 1, part 2 again, because absolute value is everybody's favorite. Question on this before? Yeah, for sure. Yeah, for sure. Okay. So, let's make something up that's similar but worse? I don't know. What do you think?
Worse, yeah.
Worse. Okay, similar but worse. I like a challenge. We're gonna integrate 2 minus the absolute value of 3x plus 1 dx. And we're gonna go from -2 to 2. It's definitely worse. I have definitely made this worse. In so many ways worse. All the ways worse. Okay. So the first thing that I want to point out, if we have pluses and minuses, split it up. At least split it up in your head, but if it helps, actually split it up on the paper, right? I've got this minus sign here. Now treat absolute values like you would parentheses. You can't break that stuff up. But here I'm going to have -2 to 2 of 2 dx minus the integral of -2 to 2 of the absolute value of 3x plus 1 dx. We cannot leave this alone. If you integrate it directly as if the absolute value is not there, you will get the wrong answer. When we have absolute value, we can either think through it graphically or we can think through it as a piecewise function, but it is 2 different functions whenever we have absolute value. Now, the reason I said this was going to be so much worse is we got fractions, but it's okay. We can handle the fractions. So I'm going to take that 3x plus 1 and set that equal to 0. So I know that I have to break this up at -1/3. Now, graphically, if we just like as an aside, and I will let you all try to do this on your own in a second and get to a number and I'll do it too, but graphically, that 3x plus the absolute value of 3x plus 1 is like a V that looks like this. Okay, except pretend it's symmetric and beautiful. And we're going from -2 to 2. But if you don't break it up, then you're treating it like it's this line. And you're going from -2 to 2. So all of this area down here would essentially get subtracted when you're doing the integration. So that's what you're doing a different problem if you don't deal with the absolute value.
Yeah.
So just remember when it's absolute value, you have to break it apart. So, okay, good times. Give this a shot on your paper. We'll see how we do.
calculate all out.
I would say that if you've gotten to the place where you have plugged in numbers, then quit. Don't try to like combine fractions and common denominators and blah, blah, blah. No. Yeah. Should we go through it?
So,
Okay. So the first piece, I don't have to break up at all, right? This wasn't really part of my absolute value, so I can just do this directly. When we find the antiderivative of 2, we get 2x, and we're going from -2 to 2. So 2 times 2 minus 2 times -2, boom, walk away. For this next piece, remember in our overall integral, we were subtracting this thing, which means I'm breaking apart that integral. And then I distributed the minus sign through. When I break apart the integral, I told you I was making a really gross one, sorry. When you break apart the integral, I'm breaking it apart at the place where the absolute value, where what's inside the absolute value is 0. And I need sort of the part on the left-hand side of that. I have to force the sign to change by putting a minus there. I think about it graphically, and I literally am thinking about, oh, I know on this side, the slope of the line is negative. So I need this one to be negative. And I know on this side, the slope of that line is positive. So I need this one to be positive. That's how I think about it. Which means, and I'll distribute that minus sign 3 times. So I've got a minus and a minus, which would turn that back around to a plus. And now when I integrate 3x squared, I'm going to have 3x squared over 2 plus x. That's going from -2 to -1/3. Here, I'm distributing that minus sign through. So this is going to be a minus 3x squared over 2 plus x from -1/3 to +2. Plug stuff in. I'm going to skip that part in the interest of making sure that we get to talk about more things. I think that this is significantly more gross than what you're going to see on a test, just given the time constraints of a test. Yeah. Right, and you could technically break this one apart as long as you did it for both. You could. You should get the same answer.
Yeah, I distribute the negative sign, so I just have like minus -3/2.
Yeah, that's fine. A minus a -3/2 is also totally fine. Yeah. And you know, sometimes as we get deep into all of these fancy methods of integration, it's easy to overlook. Like, it's easy to look at 3dx and sort of have this panicked moment of, wait, huh? What do I do? So this one really does just become 3x. If I have a 3x, don't forget there's an invisible exponent of 1 there. So I'm adding 1 to that exponent and dividing by the new exponent. Honestly, I think these are two that sometimes the simpler ones or harder to process in the stress moment because you're expecting it to be something more complicated than that. Yeah. So there's definitely a question about whether some trig stuff will end up on the exam. I really would be kind of surprised if you don't have at least one question that involves trig. So how about if we do just a tiny bit of trig practice too? Okay, we're going to play the same game we were playing on Wednesday, which is what's the method we're going to use? So I'm going to put two problems up here. I'm going to have x squared cosine x and x cosine x squared. Okay, so don't start integrating yet. But for problem one, use substitution or integration by parts? I got votes for, then I'm only looking at problem one at the moment, so I'll cover up problem two.
Say by parts, just because it doesn't plug back in very well. Still gets you with like some.
Yeah, so I think those are both good points. The derivative of the x squared is not in the function, and really the derivative of the cosine is not in the function either. So the way that I would know that it was integration by that it was a u substitution is if somebody's derivative was in the problem for us. Because it's not, this is going to need to be integration by parts. Okay, problem two. What do we think? U sub or integration by parts?
Maybe use substitution. Because subbing substitution with the first x, we got like 1, and the integral of cosine squared. No.
So there's a subtlety here, right? And so in the chat, there's a very succinct explanation here that x dx is basically going to be my du if I let x squared be u. We'll be off by a number, but being off by a number is always fine on that u substitution. These are practically the same problem. I mean, if you looked at them really quickly, the only thing I've done is move where the 2 is. So take a moment, don't rush into a method of integration. If it's a u substitution, somebody's derivative is hiding in the problem. Which one should we do first? 1? Okay, so let's tackle 1 first. I'll just kind of put a pause on 2 for a second. So if this is going to be integration by parts, I am looking at a mixture of algebra and trig. Algebra comes first in the word late. So I'm going to make u equal to x squared. That means that my du is 2x dx. By the way, if you start down this path and you notice that, oh, hey, look, what I needed was in the problem somewhere, then you know it was a u sub and you can bail, right? Unfortunately, we don't have the 2x dx and we still have a cosine, so we got to keep going. dv is going to be everything else. So now I'm looking for the antiderivative of cosine, which is and when I put all of that together, I've got u times v minus,
How do you know
oh,
V
yeah.
is positive sine of x? Because I thought it was negative.
So I have all of my derivatives memorized and I just stick to the derivatives. But if we go to the fabulous chart that we had up yesterday, where we just list out sine of x, cosine of x, negative sine, negative cosine, positive sine. As you go down, you're doing derivatives. And as you go up, you're doing integrals. So we were looking for the integral of cosine. So we're going to get positive sine. Worst case scenario, you're off by a minus sign, right? Like better to have done something and get some partial credit and be off by a minus sign. Yeah. Oh yeah, so sorry. Yeah. Yep. We can thank Angelo. He came up with that on Wednesday for us. But yeah, worst case scenario, just do something because partial credit is better than leaving it blank or sort of getting stuck and paralyzed staring at the thing. Okay, uv minus v du. So I'm going to have sine of x times 2x dx. I always pause to recollect my thoughts here. Throw all my numbers out in front so that they're not in my way. And then I'm going to look at this and say, well, it's still a mixture of algebra and trig, and I still don't have anybody's derivative in there. So I guess I'm going to have to do it again. I'm going to let u be equal to x this time, which is good because now I know at least I've reached the end. The derivative of u is dx, so I won't have to do another one. dv, as I have written it, would be sine of x dx, which means v totally. Also, I don't know if you've noticed, but whenever I do this, I always make the dv's on the bottom and the v on the top. And if you make sure to write it in that order, it's just another reminder that going up was doing integration. Okay. Pulling all of that together. X squared sine of x minus, I'm going to put brackets around this because I'm replacing the entire integral. And since I was subtracting that entire integral, I'm going to put brackets around it for now and then distribute out. So u times v, x times negative cosine x minus v du. And this is especially important for me that I'm going to take a minute to multiply all my minus signs through and make sure that I've got that settled. So here I've got a minus, which will make that plus x cosine x. I lost a 2. I sure did. Thank you. Now this one, I've got a minus over here, which would make that plus, but then I'm distributing in that minus 2. So I've got a minus 2 integral cosine x dx. And, oh, did I make a mistake again?
So for ultraviolet ultraviolet blue too, it's
Yep.
not multiplying the integral, it's subtracting the integral.
Correct. Yeah. So plus 2x cosine x. And now I'm integrating cosine. So I'm gonna have a sine of x plus a constant and finally be done.
What is the negative in the cosine? For the-
This one,
No, for the first. Oh. No, so it's x negative cosine. Ultraviolet.
yep. X times that negative. I'm distributing this -2 in.
So
So my -2 times the negative cosine, I wrote as a +2. I always take them, like anytime I'm doing integration by parts, I take a minute to rewrite that step before I find the antiderivative. Because a lot of times there's a minus sign or there's a constant in there. And so I just like to have all that settled before I take an antiderivative. Should we take a look at that second one? The x cosine x squared dx. The one that is a U substitution. Shall I let you all try that on your own? Go for it. How's it going? Did I get what you got? We got a couple minutes left. Anyone have a last thing that they want to think about? Also, before I forget, I do have office hours on Zoom from 2 to 3 today. So if anyone has some of those kind of last minute questions. Right, so how do I know that it's positive sign and not negative sign? I know. So the derivative of cosine is negative sign. We're not taking derivatives, we're taking antiderivatives. Which means this is really asking us the question, well, I didn't ever write it out in the u sub form, but cosine of u du. This is asking us the question, what function has a derivative that equals positive cosine? And that function is sine. You're gonna be great. This is gonna go fine. You know how to get some partial credit. You have skills. You got this. Make sure that you get the easier points, right? Like, look at the,
Write everything in the problem now.
look at the problem, write anything that you know that might have to do with that problem, right? Get those partial credit points. And if you look at the integrals and you're like, oh yeah, this one looks easy, get some of those easy points right off the bat. Okay, I hope it goes well.